Share screen. There we go. Okay, so we're going to start off with twisted pair cable, and it's a copper cable, so it's twisted pair. It's actually got 4 pairs, you know, so 8 cables total, all wound into one. And the reason why you have them twisted is so that the electromagnetic fields cancel out, so that you don't have as much interference with them. They do have some interference, so you can actually go to what's called a shielded cable, which will have a metal sleeve that goes around it, so it has less interference. So like Mark was saying a couple weeks back, if you have like lights in the ceiling, you don't want to run the cables parallel. You want to run them across them, just for that purpose. This is kind of a picture of what they look like. They get 4 different colors. You have blue, yellow, or not yellow, orange, green, and brown. And then each pair has a solid and a striped. And then they have a specific order that they go in when they get terminated. This is a definition of crosstalk. Basically, it's where you get interference, and 2 cables will have signals that interfere with each other, and so you'll hear what one person is saying on the other cable. So it's not an ideal situation. And then interference, you get both electromagnetic and radio interference. Here. You guys know what interference is, high school physics. So attenuation, when you send electricity across copper, well, anything really, but copper specifically, it has a resistance to it. And so you can only send it so far before you don't have any more voltage. So you have a voltage drop. And so the IEEE 802.3 standard, they did some testing and everything, and were able to make it 100 meters, which is plenty long for a building. So, and then you can actually go further than that, but you have to have a device that would resend the signal, such as a switch or a router or a repeater. These are some different categories of cable. You got Cat5, Cat5e, Cat6, Cat6a, and Cat7. I think you can actually get Cat7 now.
Yeah, you
I have not
can
seen
buy
it.
it. I said you can buy it right now.
Yeah. And like we went over the first day, you've got the 100 base T, 1000 base T. Do you remember what that meant? Basically the speed. So you can go 100 megabit with Cat5. You can do 1000 megabit with Cat5e. So gigabit, in other words. and then you can do 10 gig with Cat 6A. Technically, I think you can do 10 gig with Cat 6, but it's limited in length. You can only go like 50 feet. And just another picture of how twisted pair works. This is a shielded Cat 7, I think, twisted pair. So each pair has a foil shielding around it so that it doesn't get interfered with. This little chart gives you kind of what the different specs are for UTP and STP.
Peter, I just want to also mention that Cat 8 also available.
Really?
Yeah, you can actually buy it on the online, like Amazon or something like that. They have a 2 gigahertz, I believe. It's
Yeah,
like
that's right.
faster than Cat 7.
Almost same speed as connecting to a satellite. It's just ridiculously high frequency. So.
Oh yeah.
Yeah. And then you have riser versus plenum. Plenum is for the in the ceiling. Riser goes up through the wall. Straight through versus crossover. Okay, so you can connect these differently depending on what, I guess, your application is. Most times you're just going to do straight through nowadays. It used to be that you had a crossover in between devices, like in between switches or in between routers. You had to do a crossover cable. Nowadays it's auto sensing. So this is the order, the spec for the termination of the ends. So you go white, orange, orange, white, orange, white, green, blue, white, blue, green, white, brown, brown. That's the B spec. That's what everybody uses. But you also have the A spec, which is white, green, green, white, orange, blue, white, blue, orange, white, brown, brown. And to make a straight through, you make both ends the same spec. To make a crossover, you make one end one spec and make the other end the other spec.
What are the EIA/TIE mean?
EIA?
Same EIA/TIA standards.
Oh, I'm not sure. Probably some sort of standard organization.
So just like, but like, I'm just trying to understand like what it means by same standard on each end.
Oh, well, okay. So like I said, you've got a cable and you've got ends on them. And if you make them the same color or order, then it will be a straight through. If they're opposite, then it's a crossover.
Peter, if I was going to add to your discussion by saying that with the pattern that you see the wires as they're attached to the plug, the straight throughs obviously are going to connect. In the old days, they referred to them, what was it, DCE and DTE, where they would connect like a computer to a known terminal device. And so they'd call the computer a DCE and the other one a DTE. And so they separated that. And that just used the straight cable. But whenever you had two pieces, like two PCs, and we've kind of run into this where we want to just talk to each other, then that cable had to be crossed over because their pins for the transmit and receive bumped heads. You had T to T and R to R. Yep. So the building standards and the cabling standards, as we mentioned, the EIA said if you're going to connect two DCEs, they have to cross over. And if you're just going to go ahead and bump between types, you're okay with the straight. But as you said, now the ports are auto sensing to where they're going to figure out who's sending and then just absolutely just switch it over.
Yep. And yeah, we don't use DCEs anymore.
Yeah, that's what I'm saying. It's almost a moot point.
Yeah, it's helpful to know, but yeah, it's not critical or anything. But basically, this standard, this EIA and TIA, that's an organization that made this standard here. And I don't know what those mean. Electronic Industry Association, maybe? I don't know. But you do one or the other, and it'll be a straight. But if you do one on one side and one on the other, it'll be a crossover. And yeah, if you want to hook up two computers directly to each other, you can. You have to manually set everything up, but it will communicate with each other with a crossover. All right. And this just kind of gives you an idea of what the pins mean on your wired connectors. So if you look at the network port on your computer, you can see that it's got 8 little, usually gold colored pins, and the connector slides right on top of those pins. And then here it shows you what pairs are for data and what pairs are for power. Also, in power over Ethernet, certain devices are able to accept a certain number of a certain amount of power over network cables. So, like for example, a security camera, you don't need separate power for it. You can plug it with a power and data cable all in one. You have to have a special switch or a power injector for the on the other side in order to power it. Different terminators. So this is your standard not cat, sorry, your standard RJ45 connector. And it's a crimped connector. And this kind of gives you an idea of what it looks like when you set up the different color codes. This one's an A spec. And then we have B spec over here and A spec over here. The other type of terminator is a modular jack. You find those on the wall or in a patch panel. And they have the individual wires stripped out and then punched down into these little slots. And inside each little slot is a sharpened metal pincher, I guess you could say, and it pierces the shielding around the actual copper trace, and it then makes a connection. Same thing happens with the actual RJ45 connector, but it's a little different mechanism, and you have to use a crimper to make the pins penetrate.
I just wanted to add to that, Peter, and I apologize for interrupting the presentation, but you're absolutely right. A large pair, you've seen them at Home Depot, the large plier crimpers that you'll put on top of it, and it goes to what's called insulation displacement blades on the connector. And the trick there, of course, is to have a short length on the wire ends and to trim off the excess and to do a clean punch and not move them around a lot. I know a lot of people that you distribute your cables a lot. Those insulation displacement connectors are the first place you check if it's in a high traffic where those cables might be run into. On the other part where you showed the other modular connectors where it's a little longer into the beds where those insulation cut blades are, you use a punch down tool, which some of the guys may have seen or see the phone man use, and where they're rapidly or even a network guy where he's rapidly going across the connections and doing a double punch, which it automatically pushes the wire through and then trims the edge off that wire. Then they'll inspect it to make sure that it's seated all the way to the bottom. And but millions of these cables still exist, and they still represent something that you'd have to check on a regular basis as they age.
Yep, you're exactly right. Here's a picture of different tools that you would use as a network person. You've got a clippers, a stripper. You put the cable in through this hole here, and this part will open up, and you would then squeeze it down and turn around the cable to strip it on. And then you have connectors and a crimper. And then this box here is a tester to make sure you get a good connection on all 8 wires. Other tools you can use punch down tools like this one here, and then other cable testers that will do a remote setting. So like you can be on a different floor, you can hook up the end and hook up the tester and test the cable all the way through the building.
Hey Peter, I got a question real
Sure.
quick. So what is the difference between the gigabits RJ45 port or port and just regular RJ45 port?
Well, RJ45 refers to the connector type. So the old phones, like you would have in your house, an old wired one, would be an RJ11. The multi line phones were RJ44. And then they but they extended RJ45 for network. So then they started making different categories of cable. Ugh, I can't talk today. So you had Cat 3, Cat 5, Cat 5e, Cat 6, Cat 7, 8, and so on. But they all have the same connector, RJ45 connector. So
Peter, can I add to that? Well, I've got a lot of experience in that area, and you're right on time. I know that his question with the connectors is that oftentimes when going to the higher frequency and the higher transmission rates, your medium, the type of copper or the number of twists, some of those have got gold contacts in them for the high end, super high frequency stuff because of the conductivity. They don't want any oxidized, pins in there to slow down the transmission. So I absolutely, in 1 year, bought cheap cabling where the twisted pair count was good, but the twists were so far apart that it had interference when you neared that 125-foot length, and you couldn't even use the cable. So it wasn't even really correctly rated for Cat 5. It wouldn't work. So in answer to the question about the difference between the categories, you're right. The connector is basically the same. Sometimes the blades are different, and they're under more stringent rules that when you're using them, you've got to have perfect crimps, clean cuts, and you don't want a cheap type of medium. The medium itself can cause you headaches, and it has to be a Cat 8 specified because of the twist if you're using copper. And a lot of cabling companies don't tell you this, but sometimes the wires are made out of nichrome or some alloy that's cheaper that is still marked as a network cable, but is absolutely useless at the high gigahertz rate. And so you just want to be careful that you get truly certified with the correct solid, copper or the solid gold connectors when you're using it that level.
I have a question too.
Sure.
Is this something that like electricians or like EEs do, electrical engineers?
Okay, so electricians typically deal with house wiring and electrical wires. However, pulling a wire is very similar to pulling a network cable. So a lot of times they'll do both.
Also, it bleeds into something else. Oh, okay, I see.
Yeah, I was going to say the cable guy now gets more training. The telecom men used to get a little training, but the cable guy now is trained on both the high end and connectors, and very few electricians. And I have a journeyman brother who's an electrician, uh, who he gets near it, but he doesn't actually have the same training or expertise in the computer cabling. So it does have a niche, and it's only now being added to some of the electricians training, but for the most part, it is still a cable guy or a strict
see.
net engineer. Most net engineers started off in some form of electrical work or telecom training, and then they end up being indispensable in data centers and places where you see those massive cable harness sections go.
Mhm.
So yeah, you're right. It is tough to pin down, but the electricians don't normally have, even with the electrical engineering guys, don't normally have a full expose into how to do punch downs and cable connects as the ones we're talking about anyway.
Mhm.
Does that answer your question, Micah?
Yeah. So those two groups, the networking and then the actual electricians, and then I'm assuming there's a separate entity for fiber optic, or is that the same thing ish?
Most cable companies will do fiber as well as copper,
I see. Okay.
and fiber is a whole other procedure and a set of tools for crimping and terminating.
Okay. Thanks.
Usually a lot more expensive tools. Speaking of fiber optic, basically it's a cable that will pass light through it. It's usually made out of plastic or glass, and it can be doing very long distances and very high speed. We've got two different kinds, single mode and multi-mode. Multi-mode, you have different frequencies that go through it, and then single mode is only one frequency. And this more expensive equipment and less expensive equipment, no, it's not true anymore. It's basically the same now. The multi-mode slightly cheaper as far as the cable goes, but they've gotten real close in price. All right, so this is different fiber specifications and different speeds up to 10 gigabit. The LR stands for long range, SR short range, and you can see they're only rated for like 80 meters or so, whereas the long range can go up to 25 kilometers.
Hey, Peter, are you familiar with the lucite? When you were talking about plastic or glass, were you talking about stuff like the lucite, which is like that super clear plastic that they use as an optic transmitter?
Yes.
Okay.
Yeah, most of your multi-mode is plastic. That's why it's cheaper.
Okay.
But they've gotten the manufacturing process for glass. They do such a volume now because every like national carrier. Yeah. Every national carrier uses single mode because it goes farther, and so the price has come down really well.
Thanks.
Any questions on the different standards? And we got to move on to wireless. Bane of my existence. Wireless is really good when you have like 5 or 6 people or less. Anything more than that, and things get hairy. Okay, so at your house, typically, if you've got cable or I guess AT&T, they'll have it in their router. They'll have it as an access point, all in one. So that will transmit wireless signal for you. Sometimes it might be better to turn that off and have your own wireless system, depending on how big your house is. So there's two different modes. Ad hoc isn't used very much, except for maybe printers, but infrastructure is what most people use it for. You'll have one access point that goes out to the internet, and everybody connects to that access point. All right, so wireless LAN or WLAN.
Could you slow down a little bit? I'm having trouble tracking up,
Yeah.
keeping all these
Oh,
notes.
sure. I'll go back.
Peter,
Also,
would
I'm
you consider the
recording this.
definition of ad hoc really close to peer-to-peer, or would that be overstepping in terms of how they connect?
Yeah, that's exactly it.
Okay.
It's a peer-to-peer. So your Internet of Things typically will set up a little ad hoc until you tell the device what SSID to use, and then it will then use infrastructure. So, you know, like RGB light bulbs and things. So anyways, as I was saying about a WLAN, WLANs are typically, I guess, broadcast an SSID. You can also turn the broadcasting off and still have that SSID you can connect to. An SSID, basically, it's the name of your network. So if you're at home and you call your network the Batcave, the SSID is the Batcave. So. And also, I'm recording this so you can go back and watch again. Also, the presentations for this today are in Moodle. And then other wireless devices would be a repeater or a wireless bridge. Somewhat uncommon.
Peter, can I get, and this is just me more or less just picking your brain about the use of the phrase wireless bridge. And whenever I hear the word bridge, it's me thinking about larger devices, for example, two routers speaking to each other, or two, kind of core base devices communicating, as opposed to individual users connecting. Would that be an incorrect assumption? Is a bridge usable, I suppose, between a single user and another repeater? But I don't know.
So bridging refers to, like what you said, having two routers talk to each other. You can turn your computer into a router by putting it into bridge mode. So technically speak, you could do that. Most people don't. Like I said, this is fairly uncommon.
If I remember correctly, the bridge, you connect those two routers together and you set the channels for each router that does not interfere, and then you're using same SSID for both of them, and you just back and forth wherever it closer to aspect of the coverage, then your device picking it up, and they just switch the channels. That's what for the bridge mode, and the repeater is just simply amplify the signal to the other. Generally require the Ethernet cable. I don't know the theory behind of it, but you don't have to touch anything about the channels or whatnot for the repeater.
You probably have it on different channels, just
Oh.
because you don't want it to interfere with each other. But yeah, you're right. So different standards of Wi-Fi. So they started out with A, which was on a 5 gigahertz frequency, and then they moved to 2.4 with B and G. And then in order to get faster speeds, they combined them with 2.4 and 5. And then AC apparently uses just 5 by itself. And then AX is back to using both. And it's basically faster, faster, faster. Different encryption. So when they originally did the Wi-Fi, it wasn't encrypted. You know, all this network stuff, when they first come out with it, it's completely wide open. Primarily, I guess the engineers just decided, hey, let's have a party because we can actually get things to talk. And so, and later on they go, wait, we need to secure this because people can listen to this stuff. So they've come up with different encryption options. WEP was the first one and no longer used. It's been broken hard, like it's real easy to break. So, and then they came out with WPA and WPA2. WPA2 is kind of what most people use nowadays. You get 256-bit encryption on it. TKIP and AES are two different encryption schemes that you can use within WPA and WPA2. It's like double encrypted. All right, service set identifier. It's also SSID, and we already kind of talked about that a little bit. This is just an example of what some wireless settings would be on a, looks like an access point. In this case, it's got 802.11n only, channel 11, 40 megahertz channel width, so you can make the channels larger and smaller. The smaller they are, the less speed you can have, but more people can use the amount of bandwidth you've got available. So if you've got a high density environment, you want the channel width to be smaller. And then the WPA and pre-shared key. Okay, so pre-shared key, you make up a password and then you have to install that password on the client as well. So like when you ask, hey, what's the Wi-Fi password? That's the pre-shared key. That's basically just a summary of what we just talked about. Any questions about it?
I do have a question, but it's not exactly about this. It's about the quiz.
Okay.
First of all, it says it's on next week, but it's actually like it starts.
I know. Moodle's all messed up. Yes, we pushed it back to next week, and it's going to be a take-home quiz. So.
Well, it's 45 minutes time limit, and
Right.
it closes on Monday.
I know. Like I said, it's all messed up. We'll have it fixed. So.
What's the quiz going to be on exactly?
Mark has got that taken care of. I'm not sure exactly. Pretty much the things that we've been talking about: data centers, cable types.
Just like the basics, or?
Just the basics. Again, it's a take-home quiz. So open note, open internet, whatever.
And like, you will remove the time limit, I am assuming, or?
I think it's only 10 questions. So should be able to do that in 45 minutes, huh?
Just wasn't sure if that was part of fixing it or not.
Fixing the time. That's what I meant. All right, so let's go about DHCP.
Oh, Peter, I just remembered one question to ask you about the cabling thing. I know that Mark touched on it, and that was the color coding of some of the fiber optic cables. And obviously, when I used to work with regular Cat, Cat5 cabling, you could make them multicolor, but oftentimes that had nothing to do with, what they were. But I think with the fiber optics, we know that we saw the orange and the white, and we saw some other differences in those. Could you kind of recap that, or give me a place to look for the standards on those?
Absolutely. Okay, so there is no standard for coloration. However, fiber optics, typically orange is going to be multi-mode, or teal. The new color for multi-mode is teal. And then single modes is yellow. But again, there's no real standard. I've seen red fiber cable before, and green. So, and then as far as Cat5 or Cat6 or anything like that, they come in all kinds of different colors. I've seen pink, yellow, purple, orange, blue, whatever.
In years past, I've had people ask me to get them a matching color to their room decor. So it was pretty silly. This question comes up a lot for me because you walk into a hospital and have the honor of walking by their IT sections, and you'll see 3 or 4 types of cabling all piling in there, and you'll see a lot of the yellows distributed, in vast, and then it'll all tighten up, and oftentimes their big server areas are all connected then, of course, with the orange, and you kind of get an idea of why they do that, but I did not remember what the definition.
You can come up with your own color scheme.
Okay.
So if you want, like, for example, here at the university, we have things color coded, at least in theory, in the closets. Like purple cables will be for cameras. Green cables will be for access points. Red cable is your uplink. Gray, just a normal computer, that type of thing.
Now that leads me to my other attaching question, is that here you've got all this cabling throughout the university on all the wall plates or all of the repeater sections. Do you guys index them or mark them a particular type of code or coding that will help you locate that on your screen?
I really wish they would. But
Okay.
every building has a different scheme. And then some of them aren't even labeled. So, yeah. Welcome to networking.
Yeah.
Any other questions?
No, thank you, Peter. That was perfect. I appreciate that.
All right, so DHCP. So anybody know what DHCP means? Or stands for? Anyone besides Jonathan?
It's dynamic host configuration protocol.
Correct.
Or control protocol, yeah, DHCP. There you go.
It's configuration protocol.
So what does it do for you?
It's a protocol that allows you to connect to a network with the different IP address each time you connect to that network.
You're close. That's close. So we'll go through it here. But
Oh, yeah.
basically, you're right. The dynamic part of that means that your IP address could change. So this is what we're going to kind of talk about, what the server does, how to deploy it, and managing and troubleshooting it. So benefits. So in a small network, it's real easy to just say, you've got 192.168.1.1, and you've got 192.168.1.2, and 3, and 4, and 5. And if you've got 10 people, it's pretty easy just to manually do everything. Whereas if you got 100 people, then it's a lot harder to just manually do all that. So they've come up with DHCP to have the IP address allocation to be done at the server level. So you have a DHCP server, which then hands out addresses to the clients. Let's see here. Looks like we're going to do our first lab on Thursday about IP addressing, subnetting. Actually, I take that back. Might be the 16th. Well, the week of the 16th. Yeah, we've got to get these organized a little more. Sorry about that. Okay, so back to DHCP. In order to hand out those addresses, you have to do what's called a lease. And the reason why you have a lease is so that the allocation can expire. That way, the client, if it's a laptop or a phone or something like that, it can move out of the network, and then that address can be used again for somebody else. And then if for some reason the person that has an allocation didn't move out of the network, then the lease would expire, but then it would get renewed before the expiration happened. So when you said your address can just change, not really. If you get the address to begin with, it will continually renew the same address for the most part. And basically, it just makes things easier on us people that manage the system. It's much more automatic. All right. So when we talk about a non-DHCP client, it's going to have a static IP. In other words, you manually put in that IP address. And every IP address on your network cannot have a duplication, because they have to be able to talk, and the packets have a source and a destination, and they have to be unique, because otherwise it won't work. So in order to do that with the DHCP server, it keeps track of individual people that have individual leases. So some people will be generating, and some people will be renewing, and some people will be dropping off. You can also have more than one DHCP server, and they'll talk to each other and share the configuration between them. And that way they can serve more people at once without getting overloaded.
Hey, Peter, do you know whether or not if you have multiple DHCP servers, whether they have to be on the same operating system, or is there an shall we say, an accepted or standardized version of DHCP behavior?
Okay, so DHCP is a standardized protocol. So in theory, one DHCP server can talk to another. In reality, if you have a Windows DHCP server and a Linux DHCP server, they're probably not going to share the configuration very well with each other.
I
So
asked
you
that
wanna have one
question.
kind.
I thank you so much, because I asked that question because I've seen people and they set up brand new industrial copiers that work off Samba or some other form that actually have built-in DHCP for connecting other devices to the copier, and they'll bump heads with Windows or bump heads with everybody else in the room. And you're right, they just don't play well with others. So
Yep, and I guess that is a good segue for the story I was going to tell. In my previous job, we worked at a school system, and all of the computers are on DHCP, and we have a DHCP server. And one of the teachers decided they wanted to have wireless in their room, so they brought in a DHCP router, or not DHCP, a wireless router that had DHCP. Unfortunately, they hooked it up wrong, which then started handing out DHCP addresses to all of the computers on campus. So, and of course, their range was different than our range. So like half the school couldn't get on the internet because they had the wrong IP range. And yeah, that was kind of a headache to find. Makes you want to shoot people.
I just won't tell you where the bodies are buried. They'll never find out.
So how this all works, so the client will broadcast a DHCP discover packet to the server. The server will then hand out a DHCP offer and say, hey, you want this? Does it work for you? DHCP then clients, yes, that will work. No DHCP requests. And then finally, the DHCP server hands out an ACK, an acknowledgement. Notice how all of these are broadcast. We haven't really discussed that much. You have two different types of a packet. You've got unicast, actually there's three, now that I think about it. Unicast, multicast, and broadcast. And broadcast, when it's a special type of packet, and basically it will go out and hit every node on the network trying to discover something. So in this case, it's a broadcast saying, hey, I need an IP address. I don't have an IP address. Are you a DHCP server? And hopefully one of those devices is a DHCP server. Unfortunately, if you've got, say, 1,000 computers on your network and they all broadcast at once looking for a DHCP, then you'll have a lot of congestion on your network, as well as overloading on your DHCP servers. So you want to try to limit your broadcast as much as you can. In order to do that, the hardware way of doing it is to have routers in between your segments. A router won't pass a broadcast. Unfortunately, that means you have to have a DHCP server inside the network. You can't have one over here on the other side of the router, unless, of course, you've got the router configured to allow DHCP through. It's called DHCP forwarding, and it turns it into a unicast packet. So anyway, so when 50% of the lease duration has expired, then the client will then try to renew the DHCP address. So it sends out a request. The DHCP server sends an ACK. And if it fails, it'll try it again a little bit later. And then you can set the amount of duration for the lease at the server. So sometimes you want it quick, sometimes, like in our case, it's normally around 8 days or so, but you can set it to whatever you want. And then if it loses its lease, then it will try the whole broadcast and everything back again until it finds another DHCP server. So this slide deck is Microsoft based. So this is going to go into how to
Can
enable.
you go back again? I couldn't catch all of that.
Sure. So anyways, like I was saying, this is going to kind of go into how to install it on Microsoft products. Let me know when I can move on.
Peter, I got a question in the meantime, and I appreciate your indulgence with me on this, is that you're showing that the leases are automatically renewed and we can adjust that time. Is the standard 50% of its time, or has that always been a standard? And I've noticed that it says there on the slide that when you reach about 88%, that it gives you the full handshake again, where before I'm guessing it simply send a simple renewal request, and then if you acknowledge, you're good to go. So I'm trying to pin down that process so when it's about to expire, it just does a couple of steps, but then if it does go past 88%, it'll automatically send you the full intro package or the full 4-step handshake.
Yeah, we're learning the protocol RFC, which is the standardized version. So
Okay.
yes, 50%, then before 87.5, and then after 87.5, it'll go through the whole thing again.
We can continue. I think I got the gist of it.
All right. Okay, so in the deploying part of this, it basically goes into setup of it all, and then also different options, and then the DHCP relay agent. That was what I was talking about, what you set up on the router. So it will relay the broadcasts across the network or across routers. So you go in to add Windows features, and I guess you can do it with PowerShell. You can also do it with Server Manager, and do it with the GUI. But once you've installed it, then you can create different security groups. You restart the service, and then you can authorize with Active Directory. And obviously your DHCP server, because it's a server, all your servers really should have a static IP address. I guess you could hook them up with DHCP, but inside the DHCP server, you would want to allocate addresses in a static method. They call it a reservation for whatever static addressing you want to do.
Now, Peter, does it determine that when it makes its request on an offer, and then that machine that's got the static IP, is that built in into the services, the protocol, or does that actually come from the machine from which that has to be static?
Okay. If your machine is set to static, it's not going to use DHCP, so it'll never request
Right.
it.
Right.
Okay.
Okay. All right.
That makes sense.
It does. I was thinking broadcast mode where the router was just simply sending out like who's on my network, but that's only obviously under certain conditions. So.
Right.
I've run into this where I had people have computers where they had to switch them to static because their banks required that whatever machine was actually doing the banking was required to be locked down with a static address. They wouldn't allow it to have any kind of dynamic assignment.
Yeah, I could see that. If you're trying to do something very secure, then a static address, everything all locked down and manually done. Yeah, I can see that. It eliminates the whole problem that my story where if somebody plugged in a DHCP server in their classroom, it wouldn't affect anything if everything was static.
Yeah, because those all had reservation, and therefore they're locked. They couldn't be replaced with a dynamic assignment.
Right. Now, what I was referring to when I said reservation, that's actually set up on the server side.
Okay.
So you reserve this IP address for this MAC address. And that way the DHCP server doesn't hand out that address. It just says, oh, that's reserved. I'll just move on to the next one. Does that make sense?
It does.
Okay. All right, so this is how Microsoft ties in Active Directory to a domain controller to the DHCP clients. It all kind of works as a mesh together. And what Active Directory does is it will authorize not only the user, but also the computers themselves. So we'll find it on the list, and the DHCP service starts and supports DHCP clients. Okay, makes sense. So basically, the domain controller is saying, "Are you a DHCP server that is allowed to be on a network?" And they said yes, and then of course everything gets authorized from there. And then the DHCP server 2 authorizes, apparently in this case it's not authorized, and it does not give DHCP requests. And then of course the client gets the one that's authorized because it's part of the Active Directory domain. All right, so installing it. So when you install it and configure it, you have to define what's called a scope. And a scope basically is a range of IP addresses. And you have to include the subnet mask for it, as well as the lease duration. You also want to put in a default gateway address, a DNS server, and other network options if you want to get something fancy. And then this is what I was talking about with the reservations. It can be reserved based on MAC address of the clients. These are different DHCP options: default gateway, DNS domain name, DNS servers. And then you can have, like, this scope does these DNS servers and this scope does these DNS servers, so you can kind of load balance thing just at the DHCP level.
Peter, would that also include, I know a lot of folks set up group names, not just necessarily a domain set, but group names, where if they don't have the right group assignment, then this protocol would not actually allow them to even see the other shared devices. Is that how that would work?
That's a part of the Active Directory domain.
Okay.
And yes, absolutely. I'm not sure if we're getting into Active Directory in this class.
Yeah, it might be out of the scope of the network channel, but yeah, it's on the edge of it because obviously you can hook them all up, use the domain servers to make sure everybody is seeing, talking, and capable, but you may not have the ability to physically see or interact if the AD, is in front of you. So
correct. Yeah, it controls who has access to what. All right, so let's create a DHCP scope. So in this case, we've got 2 routers, 2 sets of DHCP clients, and 2 DHCP servers. And as you can see, they've configured it with a DHCP relay agent server. So this is Microsoft's solution. Whereas a lot of times the router will have a solution as well, which will just allow the broadcast to come over the router as a DHCP unicast packet. But in this case, basically the DHCP servers will talk to each other using unicast and share the configuration from both, share the scopes and all that. And then this server will handle these clients, and this server will handle these clients, because the broadcast won't go over the router. Does that make sense?
did that slide make the assumption that you had to set the DHCP relay agent to forward?
Yeah, you have to set up the main DHCP server, and this is just the relay.
Okay.
All right, different security options and other options, failover, how to maintain the database, and troubleshooting. How are we doing on time, by the way?
I got 208, not quite.
All right. So you want to limit your physical access to the network, disconnecting unused LAN drops, and require authenticated layer 2 connections. Basically securing your layer 2 networking. Enable DHCP auditing to track DHCP usage. DHCP name protection protects. Interesting. If you have a Windows operating system computer, it can take part of the DHCP domain and prevents others from messing with its DNS. Prevents a DNS poisoning is the attack, I believe. Okay, so you can actually do policy-based assignments on all this stuff, depending on hardware vendor, users, MAC address, a fully qualified domain name, or the relay agent information.
Well, I want to say that nowadays most of the routers support ACL, active control list. So you just whitelist all of your computer device that you're checking with, and block the incoming the signal or incoming request, and then you only allow them to put it in. Well, it'll be the most safest secure measurement that you can do easily in your house.
Right.
And since you're surrounded by lots of neighbors.
Yeah. The slides we're looking at are Microsoft oriented. With networking, there's actually a whole bunch of different solutions you can do to get to the same process. I agree, you should set up DHCP at the router level. Even in an enterprise environment, you get the router involved to talk to the DHCP servers rather than having the relays and all the other Microsoft-based security. So DHCP cluster, it's where you have more than one server sharing the configuration information. And you can even split the scopes between them if you want. That way one network gets 192.168.0.1 through 150, and this one gets 151 through 254. Or you could have it on the same network and they just load balance between the two. So failover, anytime you see the word failover in the IT world, basically two devices, and if one dies, the other takes over. So it fails over. So in this case, it's a DHCP with two servers. And this kind of describes how it figures out if each of them is alive. So if it can't communicate with one of them, then obviously I'm now the only one that's left alive, and I'm taking over. That's how it basically works.
I've got an odd observation question, Peter. At the bottom it says firewall rules are auto-configured during DHCP. So given the fact that you've got a failover box and a regular box per se, and the regular box goes out, that means that all of the IP range and all of the stuff is then transferred by function over to the failover device. Does it adapt? I'm obviously that's where the question comes about the installation. Does that simply mean then that you're now on that box's pre-configured firewall rule? So it's possible you could have a firewall change in case of a failover?
Okay, so when you install DHCP on a server, it will automatically configure a firewall rule so that allows broadcast traffic to come in, and it listens for it. So that's allowed through the firewall. That's what that means.
Okay.
So you have, it doesn't really have much to do with the failover.
Okay,
They're both
that
set up
actually
the
helps
same way.
because I was kind of drawing on an inference that it might mean that it's got to take on, you know, the firewall considerations, you know, the lower or the higher security of the other device that went out. I don't know if that's even such a thing, or with tandem with tandem DHCPs, would they automatically be assumed to have identical firewall rules?
Yeah, they'll have identical firewall rules, and one will basically just say, I'm the failover, so I'm not going to hand out any requests. That's
Okay.
all the other server. And
Okay,
then if I discover the other server is dead, then I'm going to hand out requests based on the same configuration.
okay, that's crystal. I appreciate that.
Learn how to configure a DHCP failover relationship. Ooh, this will be fun. So the DHCP database, like I said, it's a common configuration, and apparently it's resides in system root, system 32 DHCP. Automatically backed up. Let's do manual. And of course you can repair it if you like. And you can move the database to a new DHCP server. Although what we do here is we'll set up a failover, copy the database to it, and then shut down the old one and rebuild it with a new version. Does that make sense? Like if we're doing an upgrade or needed a new server. And apparently you can export the data from one old server to the new server. You can use PowerShell for that. Issues that can occur when you do not configure DHCP properly. All right, so anybody want to take a stab? Address conflicts? If you're seeing address conflicts and you have a DHCP server?
Well, I think your story example kind of listed one. You're going to want to make sure that if you've got authorized DHCP devices, then you can separate them by an IP range or a limited scope for one.
Also check to make sure that you've got a failover relationship, because if they're both active, then you may have troubles. What about failure to obtain a DHCP address? How would you fix that? Or what does it mean? What'd you say, Gary?
No, I was about to say it might be a resource exhaustion. As DHCP addresses out.
Like
Yeah,
it's
or
out of addresses.
your lease is busted.
Generally, when you get a failure, that means that there's something physically problem. There's a problem with the computer. You know, the cable's not plugged in. You're not connected to the Wi-Fi, something like that. Incorrect scope, that would be a problem on the servers, and or possibly at the switch level, because it might be on a different VLAN. And we haven't talked about VLANs, but it's a way for you to have multiple networks all on one switch. And we'll go over that another day. DHCP database corruption, and we just restore for backup. And then if it's exhausted its IP address pool, then switch to a pool that has more addresses. That's pretty much it. This is all just a lab. It's just a scenario. I think we're pretty well done. Is there any questions?
Well, not to anticipate, but we'll be using the packet tracer examples and labs to kind of vet what you've just put up on the screen.
Yep.
Okay.
And we'll be doing routing in the lab, which is just to a basic network, probably 2, maybe 3 routers, and just go from there. We'll talk about it.
Thank you, Peter. That's perfect.
Sure. And that ends today. I think we're out of time anyways. So. Stop sharing.
Thanks, Peter.
Sure.
Thanks, sir.